Hi, today my group will present on the title Condition Monitoring and Fault Diagnosis on Bearing. And my group members' names are below. You can see for that. And for the introduction, is importance of machine conditioning monitoring and fault diagnosis. Then giving significance of bearing in supporting rotational motion. As per our title, it's bearing. We need to clear about the bearing. The bearing is a mechanical component, so it enables rotation or linear motion between two moving parts that will help to reduce friction and support loads. Bearing will be commonly used in machinery, automotive systems, aerospace equipment, and household appliances for enable smooth and efficient operation. As for the bearing condition monitoring, it is mainly focused on signals, vibration, temperature, lubricant properties, acoustic emissions, and the main purpose is for capturing and analyzing data specific to bring health to the machine and the bearing. For the fault diagnosis on bearing, the identification and localization of faults or defects in bearing that need to be gathered. For the utilization of advanced algorithms, machine learning, and AI, that is for fault diagnosis also. And fault diagnosis will help to understanding underlying causes for appropriate corrective actions, which happen as default in bearing. And for the benefit of implementation on bearing condition monitoring and fault diagnosis, we can improve machine reliability and increase uptime and reduce maintenance costs and optimize spare parts management. Therefore, we know that the which is the part is default in bearing and be able to uh, maintain it and enhance safety and improve operation efficiency by conducting the condition monitoring and fault diagnosis on bearing. That's all from me. The next part bearing definition.
Hi, my name is Hai Wong Jie, matrix number B0920100016 from 3BMMS1-1. Definitions will be discussed according to the keywords of the topic, which are condition monitoring, fault diagnosis, and bearings. For condition monitoring is the process of regularly or continuously assessing the condition of a machine, equipment, or system to detect any changes or abnormalities that may indicate a potential failure or degradation in performance. It involves collecting and analyzing data such as vibration, temperature, pressure, or other relevant parameters to identify potential problems early and take proactive maintenance actions to minimize downtime, optimize performance, and reduce costs. For fault diagnosis refers to the process of identifying and determining the root cause or causes of a failure or problem in a system or device. It involves analyzing symptoms, conducting tests or investigations, and using various methods and tools to pinpoint the specific fault or faults responsible for the observed issue. The goal of fault diagnosis is to accurately and efficiently identify the problem so that appropriate repairs or corrective actions can be taken. For bearing is a mechanical component that supports rotational movement between two parts. It reduces friction and allows smooth rotation by providing a low friction interface between moving parts. Bearings are commonly used in various applications such as machinery, vehicles, and industrial equipment to support and guide rotating shafts and axles. Thank you.
Hi, Assalamualaikum. My name is Ain Bashira binti Zaman. So, why is bearing condition monitoring important? Firstly, yearly detection of bearing fault. With condition monitoring, bearing defect and irregularities can be detected yearly. Besides, deviation from normal operating condition can be recognized yearly on by regularly monitoring the state of bearing. Second, extended bearing life. With continuous monitoring and problem diagnostic enable preventive measures to be taken to reduce the element that lead the bearing wear and damage. Thus, bearing life can be increased by rapidly correcting concerns such as poor lubrication, misalignment, or severe vibration. Next, improve safety. Faulty bearing can be dangerous, especially in high speed or heavy duty machinery. Failure of a bearing can have severe implications such as incident, incidents, equipment damage, and personal injury. Condition monitoring also help in cost reduction. By recognizing bearing defect early on, critical maintenance may be performed in a controlled way, so that preventing catastrophic failure and costly restoration. Lastly, data-driven decision making. Condition monitoring push provide vital information about bearing health, performance trend, and fault pattern. This data-driven strategy improve the overall efficiency of maintenance operation.
Good day, everyone. My name is GV Ganesh from BMMM 1/1. So, today I'm going to talk about how to measure the bearing health state. There are actually several methods used. The first one will be vibration analysis. By monitoring the vibration using sensors, changes in vibration pattern can indicate potential bearing faults. The second method will be infrared thermography. Infrared cameras can detect the temperature variation on bearing surface, indicating problems such as friction or misalignment. The third method will be visual inspection. Regular visual checks help to identify visible signs of damage like discoloration, pitting, or excessive wear. The fourth method will be acoustic emission analysis. By analyzing the high frequency sound emitted by bearing during operation, defects like cracks or spalling can be detected. The fifth method will be wear debris analysis. Examining wear particles from the lubricant or filters provides insight to the type and severity of bearing wear. The sixth method will be lubricant analysis. Regular analysis of the lubricant can reveal contaminants, wear particles, and changes in properties that indicate bearing deterioration. The seventh method will be temperature monitoring. Tracking the temperature of bearing help identify issues like excessive friction or damage. Thank you.
Alright, Assalamualaikum. My name is Muhammad Firdaus. Now I will cover the conclusion. Well, numerous methods such as spectral analysis, machine learning, vibration analysis, and intelligent conditioning monitoring can be used for machine condition monitoring and fault diagnosis on bearing. Numerous bearing issues including misalignment, imbalance, mechanical looseness, bend shaft gear fault, eccentricities, and bearing fault can be found and diagnosed using this procedure. It is crucial to build a database of bearing fault, including information on their shape, number, size, location, and other characteristics. In order to improve the accuracy of this technique, this database could be used to train algorithm for a particular bearing condition monitoring. Overall, the application of bearing problem detection and machine condition monitoring technique can assist avoid unplanned downtime, lower maintenance costs, and increase the lifespan of the bearing.